Hello students, today we are going to start our next topic from your class 9 and the name of the topic is quadrilaterals. Now in our previous topic which was triangles, we had learned the properties of some properties with respect to triangles, isn't it? So now in this topic we are going to learn the properties of quadrilateral, but that too we are going to see with respect to a specific quadrilateral, and it is a parallelogram. Now why we are going to go for a parallelogram? Because a parallelogram is the quadrilateral which includes very other different types of quadrilaterals such as rhombus, rectangle, square. These are all actually the types of parallelogram. So if you look for the properties of parallelogram, they are applicable to all these quadrilaterals. Only one or two properties are extra which are applicable to that respective quadrilateral. Okay, so before proceeding to that, what is the definition of quadrilateral? Yes, a polygon with four sides is termed to be a quadrilateral, isn't it? Okay, suppose I draw a polygon who is which is having four sides. So is this a quadrilateral? Yes. So what does it have? It has four sides, it has four angles, and it has four vertices, isn't it? Yes. There is one more definition of quadrilateral which says when three non-collinear points are joined in pairs, so the figure so obtained is called as a quadrilateral. Now let us try to explain like what this definition is. Three non-collinear points joined in pair. Okay. So suppose I take three collinear points. Okay. So how will I join them? Suppose these are my three collinear points. So they could be joined by a straight line. What if out of these three I am taking 2 points as collinear? So 2 points are collinear and one is not collinear. So when you join them in pairs, the figure you obtain is a triangle, isn't it? Yes. What if now there are 4 points and out of that 4 points, 3 are non-collinear? So one point will be collinear with the other ones, isn't it? Yes. So there are 4 points. Out of that 4 points, 3 I have to draw as non-collinear. Whereas one can be collinear to it, and when you join these points in pairs means this point joined with the other, similarly this with the other one, this with the other one, and like this. So the figure so obtained is called as quadrilateral, isn't it? Yes. So that is what the definition says. The three non-collinear points joined in pair are called as a quadrilateral. Yes. The another thing we could also be saying that when you are joining two triangles, the figure you are getting is also a quadrilateral. Suppose I am taking a triangle like this and the another triangle like this, and if I join these two triangles, yes, what figure do I obtain? I obtain a quadrilateral. Okay, so these are three definitions of a quadrilateral, which says the polygon having four sides or the three non-collinear points joined in pairs, whereas when two triangles are joined together, the figure you are getting it as an quadrilateral. Okay, so moving forward, let us see what is the sum of the angles of a quadrilateral. Now you have learnt in your previous class that the sum of the angles, interior angles for a quadrilateral is 360, isn't it? Yes, in your previous class, that in your 8th standard, you have learned that how can we derive the sum of the interior angles by one formula, and the formula was n minus 2 into 180, where n is the number of sides of that respective polygon whose sum of interior angles you are finding. Now in case of quadrilateral, what is n? N will be your 4. It means 4 minus 2 into 180, which gives me 2 into 180, and that is nothing but 360. Okay, so from this formula we know that the sum of the interior angles of a quadrilateral is 360. Now that quadrilateral could be of any shape, it's not necessary that it should be a parallelogram or rectangle or square. Okay, so it's just a quadrilateral. So for any type of quadrilateral, the sum of the interior angles is 360. Fair enough. Now we have to prove that how can this sum be 360. So that becomes the first theorem, or you can say the first property of quadrilateral, angle sum property of a quadrilateral. Just like angle sum property of a triangle, which we learnt in our previous topic, here we are going to see what is the angle sum property with respect to a quadrilateral. So for that, let us draw a quadrilateral. You can draw a quadrilateral of any shape, not necessary that it should be of a particular shape. Okay, so this is my quadrilateral named as A, B, C, and D. Okay, so what is my given information? It says ABCD is a quadrilateral. And what do I have to prove? I have to prove that angle A plus angle B plus angle C plus angle D is equal to 360 degrees, isn't it? Yes. So what can be done or how to prove this, that the sum of four angles is 360? Yes. Can we make a use of any of the property or theorem which we have learned previously? Yes, without that you cannot prove. Definitely you have to make use of any one of the property, isn't it? Yes. Okay, so I will make a construction. Let us join AC, or let us join the diagonal. Okay, so this is my construction. It says join AC. Now when do you join AC? As you can see, you are getting two triangles. Yes. So what if I apply angle sum property to that respective two triangles, and let us see whether the sum gets me to 360. For that, let me name the angles. Suppose I name this angle as angle 1, this as angle 2, this as 3, this as 4, this as 5, and this as 6. So that it would be easier for me to frame the equation, because A will be then addition of 1 plus 6, whereas C will be addition of 3 plus 4. So apply angle sum to the lower triangle. So in triangle ABC, by angle sum property, angle 1 plus angle 2 plus angle 3 is equal to 180 degree. Reason? Angle sum property, isn't it? Yes. Let us mark this as your equation 1. Similarly, let us apply angle sum in triangle ADC, which gives me angle 6 plus angle 5 plus angle 4 to be 180. Yes. For ABC, 1 plus 2 plus 3 is 180. Similarly, for ADC, 6 plus 5 plus 4 is 180. Okay, let us mark this as equation number 2. Now, I want to prove that this sum of all interior angles is 360. So, definitely I have to add all the angles, like whatever are present inside the quadrilateral. So, what could be done? Let us add equation 1 and 2. Yes. So, whenever you are adding two equations, how do we add? We add their LHS and we add their RHS. So, adding their LHS will give me an equation: angle 1 plus 2 plus 3 plus 6 plus 5 plus 4 equal to 180 plus 180, that is nothing but 360. Let me write it directly, 360. Okay. Further, now angle 1 and angle 6, they are actually which angle? Yes, if you add angle 1 and angle 6, as you can see, that is nothing but your angle A. So let me write down it together. So angle 1 plus angle 6 gives me angle A. Further, what is angle 2? Angle 2 is nothing but your angle B. Whereas what is angle 3 and angle 4? Angle 3 and angle 4 is my angle C. Whereas what is your angle 5? It is nothing but your angle D, and which gives me equal to 360 degrees. So as you can see, we have proved that the sum of interior angle is 360 by just dividing the quadrilateral into two triangles. In the definition we have seen, a quadrilateral is actually the what you say, when two triangles are overlapped no, when two triangles are joined together, then you get a quadrilateral. So similarly, I have applied angle sum property in the two triangles, and just I have added them and I got my required equation. Okay. So now further, let us see what are the different types of quadrilateral. Okay, you know actually the different types of quadrilateral, but here we are going to see in detail with respect to their properties, isn't it? Okay, so the first type of quadrilateral which I am taking is an trapezium. So what is the definition of trapezium? Yes, the first one is trapezium, which says that if one pair of a quadrilateral is parallel. Okay, so one pair is parallel, then it is termed as trapezium. The figure for it would be like this. Okay, now one pair is parallel means definitely this is the pair which is parallel. Then what is the condition with respect to the other pair? Like, I didn't write anything here, but is it necessary that there should be some condition? Meaning, what if I say the other pair should be non-parallel? Is this a condition? If I didn't specify this condition, what does it mean? If I am taking one pair to be parallel, it means the other pair can be parallel or it cannot be parallel. But if the other pair is also parallel, will you get a trapezium? Now, in this case, this pair is the parallel according to the definition, and the other pair, if I didn't specify the condition, that other pair is also actually parallel, isn't it? So, does the figure is a trapezium? No. So, which means either you say only one pair is parallel, or you can say one pair has to be parallel and the other pair has to be non-parallel. Let me write it as only one pair has to be parallel. So, it automatically means the other pair has to be non-parallel. Fair enough. Now the non-parallel sides, if they are equal in length, okay, suppose this is my AB and this is my CD. If AB equal to CD, which is at the non-parallel side, then we say that it is an isosceles trapezium. It is an isosceles trapezium if the non-parallel sides are equal. Second, the next definition is parallelogram. Now by the name itself, you should be knowing what is a parallelogram. It is an quadrilateral in which both pairs of opposite sides are parallel. Both the pairs are parallel, isn't it? Suppose this is my one pair and this is my another pair. So as you can see, AB is parallel to CD, whereas AD is parallel to BC. Yes, so both opposite pair is parallel. Hence, it is called a parallelogram. Parallelogram, isn't it? The third definition is of a rectangle. Now, what is the change in a rectangle as you compare it with parallelogram? Rectangle is a one type of parallelogram itself. Only the condition is the angle is 90 degree. Okay, so rectangle is a parallelogram with one angle as 90 degree. Okay, so even if you take one angle as 90 degree, by co-interior angles you get all the angles as 90 degree. Okay, so the whole all four angles as 90, it's not required to mention it. You can just say that rectangle is a type of parallelogram in which one angle is 90 degree. What about square? Yes, is square a type of rectangle? Yes. Now when you are saying square a type of rectangle, so the properties of rectangle also included, whereas rectangle is a type of parallelogram, so properties of parallelogram also included, meaning both pairs are parallel, angle is 90 degree. Which is the extra condition? It says it is an rectangle, or it is a rectangle in which all sides are equal. So this is the extra condition with respect to square. It is a type of parallelogram in which all sides are equal. Next one is an rhombus. Yes. So a rhombus is a parallelogram in which all sides are equal. Okay. Rhombus is not a rectangle, neither a square, because the rhombus is a type of parallelogram with all sides equal. Now the difference between the rhombus and square is, in a square the angle is 90 degree as well as the sides are equal, whereas in rhombus only the sides are equal. There is not any condition specified with respect to the angles. Okay. Further, which is the quadrilateral remaining? It is an kite. Now kite is neither a parallelogram, yes, nor a trapezium. Why? Because in kite the sides are not parallel. Only the definition says adjacent sides are equal. Adjacent sides are equal in a kite. So this is the figure for kite. These two are the adjacent sides, so they are equal, whereas these two are the another pair of adjacent sides and they are also equal. Okay, so this is the definition for kite, which says that adjacent sides are equal. Okay, so as you can see, I have written the type of quadrilaterals, and here we are going to see the properties with respect to parallelogram, as rectangle is also type of parallelogram, square is also type of parallelogram, and rhombus is also type of parallelogram. Okay, so when you are studying parallelogram, actually you are studying all these other quadrilaterals as well. Only with respect to trapezium we will be looking at like one or two properties, they are being followed it, or there's some questions on that also. And the last one is kite. Okay, so if I try to draw a tree diagram for the different types of quadrilaterals, so how it could be. Okay, let us see. So the first top heading would be an quadrilateral, because we are going to see the types of quadrilateral, isn't it? Yes, one type is trapezium. Further, another type is parallelogram. Now in an parallelogram, one is rectangle. Yes, which is the another one, which you can write. What if I write the another one as rhombus? Because rectangle and rhombus don't have anything in common, isn't it? Yes, rectangle is a type of parallelogram with angles as 90, whereas rhombus is a type of parallelogram where all sides are equal. But if I take rectangle and rhombus together, the property of rhombus, all sides together, and the property of rectangle, angles as 90. So if I take them together, the quadrilateral I get is a square, isn't it? And the last one, kite, which is not included in any one of this type. So this is the figure for it. Yes, if you try to draw a represent it through a Venn diagram. Yes, so the bigger set, quadrilateral, trapezium, whereas kite, individual sets, right? A bigger set into a quadrilateral is a parallelogram, rectangle, rhombus, and the intersection would be a square, which gets the property of rectangle as well as the rhombus. So this is the classification of quadrilateral depending upon their properties. Okay.